In this video we're looking at probe matching, which is the ability to match a tristimulus to a spectro such that the tristimulus becomes as accurate as a tristimulus on the display that the probe matching is configured on, obviously depending on the probe matching algorithms used. More on that a little bit later. So probe matching is within the profiling window, and under probe options you have the ability to configure the probe matching, which is to configure the active probe, which is the tristimulus, and the reference probe, which is the spectro, both on the same display. The display is important because different spectral responses do produce different results in the probes, so you need to match on the same display for the best accuracy. One thing that's very important with ColourSpace is that you don't need to do probe matching in advance of actually profiling a display, because probe matching is actually retrospective, which is very unique. I don't think this is something that any other system is able to do. So, for example, we're working with an ASUS display here just for the demonstration, and we previously profiled it using the i1D3. There we go, SD raw display. So this was profiled using an i1D3 probe, and if we connect to it, just using the generic CMF setting, not one of the other presets that are supplied with ColourSpace, on the basis that we knew we were going to then match to a spectro, in this case an i1 Pro 2. So having made the profile, we can now do the probe matching. So if we open up configure, we strike new and input a name for the first probe. Now this is going to be the i1D3, so we're going to call this i1D3 ASUS, just so as we know the display and probe combination. I'm not going to bother with the ASUS name because I've only got one ASUS display here. We will then pop up the patch, and just so you can see what a patch is, there we go. The probe is on the patch, and within the active probe settings configuration, we will measure all, and it will cycle through the red, green and blue, taking 3 measurements of each, and then do white as well. Okay, so we now have the measurements for the i1D3 on the ASUS using the red, green, blue and white patches. Okay, we will now disconnect and select the i1 Pro 2 and connect to that. Now I'm going to, before I do anything, I'm going to do a probe calibration on this. If I didn't, it would pop up a warning to say that it's not been done. So I've got the probe on its tile. Okay. Okay. Now I put it onto its hanging base so I can hang it on the display. I'm obviously using the patch to the side of the window, just so as you can see it, the same way as I did with the i1D3. In fact, if we just do that so it can be seen. Okay, and we're going to configure new i1 Pro 2 ASUS. Okay, measure all. Now obviously we could use the individual measure buttons, or we can actually edit the data manually if you want to use external software for taking the readings. Obviously slower than the tristimulus, which is why we do probe matching, because spectros are too slow for use for doing large patch set measurements. And there we go. So we can now set up the I1 Pro 2 as the reference and the I1D3 as the active probe. But nothing's really happened because obviously all these measurements were taken previously. But if we now go into graph options, we have probe matching active. And when I click, you can see that the data adjusts because it is now applying the probe match that we've just done to the pre-profiled measurements. And again, we can literally toggle between probe active and probe not active. Now we are using, in this instance, something that we call FCVM, 4-color volumetric matching. This is unique to ColourSpace because it uses the 4 colors, red, green, blue and white, but rather than using a standard 4-color matrix method, FCMM, which is used by just about all other software systems for probe matching, we actually generate a volumetric object from the active and reference data using all 4 colors, including the luminance value for all 4 colors. This gives us the ability to be very accurate on displays that very specifically are non-additive, and that is most commonly the WOLEDs, where there is an additional white pixel. So this compensates for the issue there. But the FCVM method is so accurate across the board that we use it for everything, and we do not use FCMM at all. There is an additional method for doing probe matching though, and that is multi-point matching, where we can actually use a cube-based set of values rather than just the 4 colors we see here. To perform true multi-point volumetric matching, we need to use a cube profile. We don't need to use a huge size. I mean, obviously that will depend on the accuracy of your probes in use. But we're going to do a small set of 5 here, so just 125 frames. At the moment, we're still connected to the I1 Pro 2, so we are going to perform a characterization using that on, again, the same display here, obviously. So we're just going to click Start, and we're now going to measure 125 patches using the I1 Pro 2. While this is happening, we can actually see the measurements building up on the graph, and we can actually flick between the graphs. We can obviously filter out what we don't want to see, but we can actually see the measurements coming in as they build up on the various graphs. Okay, that's completed. We did cut through a bit of that just to speed up the video. You can see that's finished doing 125 patches. We now want to save that profile, and we will call that I1 Pro 2 ASUS and give it the multi-point volumetric match name. And now we change the probe over to the I1 Display Pro, again with the generic CMF selected, because we're not going to do anything different, and go back to our characterization, and using the same size of cube, we're going to just reprofile that, but this time with the I1D3. Okay, that's the I1 Display Pro complete. And again, we want to save that as I1 D3 ASUS multi-point volumetric match. Okay. Right, those obviously don't yet appear in our probe matching data list because at the moment they are just standard profiles. So in the library we will now select from our profiles the ones we've just done, and we are going to modify, and we're going to extract a BPD, which is the file used for probe matching. And you can see this is the location where the existing ones are held, and we're just going to save it into there. And then we're going to do the same with the I1D3, extract and save. And they now appear in our drop-down lists. So we can actually select the I1D3 as the active probe and the I1 Pro 2 as the reference probe. And as before, they can be applied retrospectively. So we happen to still be looking at the profile made with the I1D3 using the 5 cube size. And if we apply the probe matching, we can see the difference that the probe match actually makes. One thing to note about multi-point volumetric matching is that the profiles initially made using characterization need to be done on the display in the state that it's going to be fully profiled in. What I mean by that is that if the display is going to be calibrated, it needs to be in its raw state when the probe matching is done. And then if you want to verify the calibration after the LUT is applied, you will need to reprofile it in its new calibrated state. The reason for that is that the gamut variation can be very large and can cause issues when using multi-point volumetric matching. As you can see, if we open up the original profile for the ASUS display, you can see that the gamut here is very large compared to the gamut of the display, obviously when it's calibrated to Rec 709, and all the measurements I've been doing here have been based on the display when it's in its roughly calibrated state. Obviously we do so many variable things here with our displays, they're never perfectly calibrated for more than a few hours. But just remember that, yeah, if you want to measure a display with a wide gamut like this using multi-point volumetric matching, it needs to be in this state before you do the initial profile to generate the probe matching files, and then you must redo the characterization when the LUT is applied if you want to then do a verification. To be fair, even when doing the ColourSpace standard 4-color volumetric method, or actually on any calibration software using any FCMM method, it is always better to rematch the probes after calibration if the gamut of the display changes dramatically from wide gamut to narrow gamut, as the differences can cause issues with probe matching. So this is pretty much a standard procedure to take if you really want to verify how accurate the final calibration really is.